Hello everyone, welcome back. This is Engineer Hussein Mwasapi. So in this video, we'll be looking at what is known as curvatures and radius of curvatures. So we'll be looking at the aspect of us learning how to find the curvature and the radius of curvature. Alright, so before we begin, do not forget to like and subscribe. Alright, let's begin. Now when it comes to the word curvature, you need to be mindful that this is simply just the magnitude of the rate of change of theta with respect to the arc length. The arc length is mostly symbolized as S, like that. Therefore, curvature in most cases can be written as P being equivalent to the magnitude of the theta over the arc length, like that. This is food for thought for you to know. When it comes to the radius of curvature, this is just simply the inverse of the curvature value that you found. Now, basically, to understand this, let us know that, say, we have a function y. In most cases, y can also be written as f of x. If we want to find the curvature, or we can write it as k, be mindful that we use the formula, which is the magnitude of f prime prime of x, which means the absolute value of that second derivative at x, over over 1 plus, so let me write it like this, over 1 plus f prime of x squared, then this is all to the power of 3 over 2, like that. So this is the formula. Now other people prefer using the formula where you write it as k being equivalent to, I mostly even prefer this one, y prime prime over 1 plus y prime squared, and then this is all raised to 3 over 2. So you can either use this one here or this one. But the inverse of, the radius is simply just the inverse of k. So the radius of curvature is simply just k to the minus 1, or others write the radius of curvature to be 1 over k. Now let's see to it that we use these formulas in, let's say, a problem. Say we have examples, and the examples are saying find the curvature and the radius of curvature. Say we have the first function, which is say y, and let's say f of x. F of x is equal to x squared at x is equal to 0. Now be mindful that f of x is the same as 1 having y. So from the formula that we were using to find the curvature, so it's a solution. To find the curvature, we say curvature is equal to the absolute value of y prime prime over 1 plus y prime squared to the power 3 over 2. Now basically you can just collect data and understand that this is the same as one writing the absolute value of f prime prime of x over 1 plus f prime of x squared raised to 3 over 2. So with this in mind, our data will represent the following. So let us find firstly the first derivative. We know that f of x is equal to x squared. So f prime of x will be equivalent to 2x. That's the first derivative. And the second derivative will be equivalent to just 2. Therefore, if we try and find the value of f prime prime at x, of which x is 0, then f prime prime will basically just be 2. So therefore, here you have, since we need to find this guy and the guy on top, let's start with the guy on top. F prime prime at x, f prime prime has no x term, it's just coming out as a constant, so we'll just maintain it as 2. So we say 2. In fact, let me put the absolute value of 2. Then the bottom should have 1 plus the first derivative evaluated at x is equal to the value given in question. Now the first derivative is this one here. Now the first derivative, which is f prime of x, which is equal to 2x, evaluated at that point, you will have 2 times 0 being 0. Therefore, you have 0 squared, and all this will be raised to 3 over 2. Therefore, the curvature will be equivalent to the absolute value of 2, which is basically just 2, over 1 plus 0 squared is 0, and this is raised to 3 over 2. This will be 2 over 1 raised to 3 over 2. Now 1 raised to anything will just basically be 1. So you have 2 over 1 giving you just 2. So basically it's about you just manipulating the formulas and seeing to it that you manage to plug for the values. Now to find the radius of curvature will just simply be 1 over k, which will simply just be 1 over 2. And this is the radius of curvature, like we explained from these formulas. Now at first glance this might not be that easy to understand, so basically let me try and give you another example to understand. Let's say we have another example. In this case we have y being equal to, say, 5 minus x cubed at x is equal to 1. Now we need first to find, because if you remember from the formula, the curvature is equal to the absolute value of f prime prime of x over 1 plus f prime of x raised to the power of, so it's a squared and raised to the power of 3 over 2, like that. So that is basically the formula. So that formula we can either just find the first and second derivative. So the first derivative will be y prime, which will be basically minus 3x squared. And the second derivative is y prime prime, which will be minus 6x. Now evaluating these derivatives at x is equal to 1, y prime at x is equal to 1 will basically be minus 3 times 1 squared, which should give you minus 3. Then the second derivative at 1 will basically give me minus 6 times 1, give me minus 6. If I plug these values into my curvature equation, I have the curvature being equivalent to the absolute value of f prime prime of x, and f prime prime of x is y prime prime, which is minus 6 over 1 plus f prime at x, and f prime, which is the first derivative at the x evaluation, which is minus 3 squared, and all this is raised to 3 over what? 2. Then the curvature is equal to the absolute value of minus 6. You get a positive 6 over 1. Now minus 3 squared, that would be a plus 9 to the power of 3 over 2. And the curvature would be 6 over, this will be 10 to the power 3 over 2. Now if we evaluate this on our calculator, we'll get a value of 0.19 as our curvature answer. Now that we have our curvature, we can easily just find our radius of curvature, where we say the radius is equal to 1 over k, and this will be 1 over 0.19, and our radius of curvature will be equivalent to 5.26. This will be our radius of curvature, 1 divided by 0.19. Now be mindful that all my answers are being rounded off to 2 decimal places, so do not get confused. Alright, now this is not really the end. There's one more type of problem that might be phrased, and this problem is where you're given a parametric form. So in a case where you have a parametric form, the formula for the curvature will not be the same. The curvature will be equivalent to the absolute value of x prime, y prime minus y prime, x prime prime over x prime squared plus y prime squared. And this entire thing will be raised to the power of 3 over 2. Now, let me try and give you an example of what I'm trying to illustrate. Let's say we have a function y being given as sine theta. Then we also have x being given as cos theta. Then I give us at the point at x is equal to 1. And some condition maybe where you'll say theta should be less than or equal to 0 and less than or equal to pi. Theta, sorry, should be greater than or equal to 0 and less than or equal to pi. That's what I was supposed to say. All right, so now from the formula that we have under the parametric form of curvatures, we're having the absolute value of x prime, y prime minus y prime, x prime prime. And this is over x prime squared plus y prime squared. And the root of this is to the power 3 over 2. Now all we are supposed to do here is simply just manipulate our problem and see to it that we can find the values that are needed for our equation. So if we try and manipulate here, we'll first start by differentiating the given functions. We'll differentiate the y and find y prime. The derivative of sine is cos theta. So the derivative of sine theta is cos theta. Then the derivative of cos theta for x prime will be negative sine theta. Now we also need to find, because it's x prime y prime, and we also need x prime prime, and we also need just need y prime, but we need x prime prime. So x prime prime is going to be negative cos theta. Now we need to evaluate these particular conditions at a given theta point. So what is the value of theta? Now in most cases, be mindful that theta will be hidden in the question. You've been given this condition for a reason. At times I might even give you y instead of x. Now when I say x is equal to 1, it means I'll get that function that as x, which is x is equal to cos theta. Once I do that, I'll plug in for x, which is 1 is equal to cos theta, which means cos theta is equal to 1. Theta is now equal to cos inverse of 1, and theta will be equivalent to the cos inverse of 1 is basically 0. So we'll have theta to be equal to 0, because theta is greater than or could be equal to 0, but less than or equal to pi. So always, to find theta, always look at the condition given. At times they might even give you y. They could say, for instance, y is equal to 2, or maybe let's say 0.5. If say y was equal to 0.5 here, in your head, and you try to evaluate it, you might find that, okay, if at all, it's just food for thoughts. If at all it wasn't at x is equal to 1, rather y is equal to 0.5, all I've done is to use the function for y being equal to sine theta. Then I know y is 0.5 being equal to sine theta. Then theta is equal to sine inverse of 0.5. And then if you do sine inverse of 0.5, you basically get your answer to be what? 30 degrees. Now that's not the case. This is just food for thought in case they gave you y instead of x, so that you know most of the conditions that might be brought. So now we have theta. We can evaluate these points at the particular given value of theta. So at theta being equal to 0, y prime is equal to cos 0, giving me 1. Then x prime at theta being equal to 0 will give me x prime to be equal to 0. Then x prime prime at theta will give me negative cos 0, which gives me negative 1. Now with this information, we can easily plug it back to the curvature equation. So curvature is equal to the absolute value of x prime at 0 is 0, so we have 0 times y prime at 0. Y prime at 0 is 1. Then minus y prime at 0, which is as well 1. And again, x prime at 0, which is minus 1. Over x prime at 0, which is, let me do it like that. X prime at 0 is 0 squared plus y prime at 0 is 1 squared. The result of this is to the power 3 over 2. And the curvature is equal to the absolute value of 0 times 1, that is 0 minus, this will be plus 1, over, the bottom will just have 1 to the power 3 over 2. This will give us 1 over 1. Therefore, if I erase this portion here, we will have our curvature being equal to 1. Now, after finding the curvature, we can find the radius, which is just 1 over the curvature, which is now 1 over 1. And the radius of curvature is basically as well 1. So this is how you go about solving questions involving curvatures and radius of curvature. Well, there are a lot of questions and a lot of type of problems under curvatures that might be brought in a different kind of way, but in most cases, these are the most common ways I've come across. So I know at first glance it might be a bit tedious, but the most important thing is to know the formulas. If you can remember the formulas to use for curvature, it's going to be easy for you to manipulate. Make sure you know the formula to use when it's non-parametric and when it's parametric. Alright, thanks for watching. If you have queries, you can reach me up on WhatsApp on the line 077 149 5252. Remember, slow progress is better than no progress. And that's strategize before becoming a statistic. Let's try and push for that A+.